436 light-years away, a planet heavier than Earth sprints around its star, engulfed in the intense furnace of a nearby sun. Here, days last less than 2 weeks. What secrets might this world, Kepler-1246b, hold beneath its scorched surface? In 2016, astronomers spotted a subtle dip in the light of a dim, orange-hued star, Kepler-1246. This faint flicker marked a planet crossing its face, a method known as transit detection. Careful measurements revealed a world just 1.36 times the size of Earth, yet over twice as massive. Kepler-1246b became another entry in our growing catalogue of hot, close-in rocky worlds. Let's take a closer look. Kepler-1246b orbits its star every 11 days, at a distance just 8% of that between Earth and the Sun. With over 26 times as much stellar energy beaming onto its surface as we receive here at home, its year is blisteringly fast, and conditions are harsh. The planet's mass tips the scales at 2.4 Earths, dense for its size. Scientists estimate an average density of 5.29 grams per cubic centimetre, comparable to Earth's own mixture of rock and metal. Its sun, a star just 73% the mass of ours, glows at 4600 Kelvin, bathing the scene in a warm orange light. But what might greet us on the surface? With an equilibrium temperature of 554 Kelvin, about 280 degrees Celsius, even the nights could be intolerably hot. That's hotter than an oven on full blast. There may be little chance for water, at least as we know it, to remain liquid here. The high density suggests a rocky composition, perhaps with an iron-rich core and rugged, scorched plains. Models imply a tenuous or vanishing atmosphere. Intense radiation from the star could strip away lighter gases, leaving little to protect the surface from harsh rays. If any atmosphere survives, it could be thin and dry, barely more than a ghostly haze. The landscape under the fiery glare of a nearby star might appear desolate. Deep shadows, fractured ground, perhaps surface minerals oxidized by relentless heat, casting colors of rust and charcoal. There is as yet no view of oceans, clouds, or life, only a world baked and battered by its sun. Why do worlds like Kepler-1246b fascinate us? With a mass just above Earth's and similarly dense, it stands at the border between rocky super-Earths and mini-Neptunes. Its proximity to the star means it receives 26 times the light we do, a natural laboratory for testing ideas about atmospheric loss, surface melting, and planet formation. How does a planet like this survive in such close orbit? Models suggest it formed farther out, then migrated inward over countless eons, baking itself ever hotter. Its single stable orbit, no eccentricity detected, suggests a tranquil history, at least in recent times. This is a crucial clue for planetary scientists, probing how planets settle into such extreme orbits. The exact chemistry of the rocks and any remaining air remains out of reach for now, but studies of similar exoplanets hint at a world ruled by geology, gravity, and the relentless power of its sun. Could humans ever walk this world? The numbers tell a challenging story. Day and night alike, surface conditions may soar well past the boiling point of water. Without a robust atmosphere, radiation from the star would rain down unfiltered. Any visitor would need protection from heat, radiation, and perhaps crushing gravity. A surface gravity possibly higher than Earth's, compressing each step with extra weight. The sky, lit by an enormous orange sun, could appear dimmer than Earth's, but far more intense. Here, even the sturdiest explorers would find little comfort. Kepler-1246b pushes the limits of human endurance. From 400 light-years away, Kepler-1246b offers us a glimpse of extremes. A dense, superheated planet orbiting a warm orange star. Studying its harsh reality helps us understand not just exotic worlds, but our own planet's fragile place among them. In the darkness of space, such odd neighbours remind us how rare and precious home can be. Kepler's echo, where science meets wonder,